Hey there, CNCers! Scott here again for CNC Labs. This video is long overdue. We've kind of been behind the scenes quite a bit for the last few months trying to perfect this process, so bear with me as I mumble my way through this video. At the end of the day, we wanted to make a tutorial video so that basically anybody could make their own guitar. It is the defining reason why I actually bought my long mill in the first place. All the other stuff is really cool, but I've been playing guitar since I was a wee young buck, and you know, it's really cool to buy one, but there's something different about making your own. That being said, the process, there's a lot to it. So I wanted to break it down to make it kind of as simple as a guitar could be. It's an intimidating thing right off the bat. I have to say I was pretty intimidated going for it. So for the next couple of minutes, the intro that I'm doing right now is going to basically lay out how this guitar series is going to roll on. I tried to come up with a really, you know, rockin' name for it, but I just drew a blank, so it's the guitar series for now. I wanted to put together just a couple of really key points, more of a learn from my mistakes, so that it'll make the process easier for you guys. That being said, I think I've already alluded to it that this is a series of videos, so we have not decided just how many yet, but there's going to be a good handful. Again, we tried to break it down, so there's no point in having one 12-hour-long video or however long it takes. So we've broken it down so that, you know, we'll run you through in basically the second half of this video is going to be about OnShape. After going through the process and chatting with a couple people out in the community, I came to the conclusion that what is the point of giving you guys files if you can't customize the files for, you know, for your specific parts that you're going to buy. That would, you know, make me angry. So we decided we're going to teach you guys a little bit of OnShape. The next one will be going through the tutorial for carving the body. Again, I tried to think through this process of how I would like to watch the video. So in my opinion, and I feel free to throw it in the comments. I mean, we're all here to learn, right? I thought, let's teach people how to modify, the 3D model that we're going to use so that they can customize it to their specs. Let's carve the body. Let's do the electronics, because the videos that come after that are, you know, carving a neck and doing a fretboard. And again, not everybody's going to want to go that route. So if you wanted to buy your own neck, the videos are going to roll out in a way so that you can, you know, customize it, do your body, do the electronics, and then bolt on your neck and you're playing your guitar. And then if you want the extra pain in the neck, for actually carving your neck, carving the fretboard, and doing all that stuff, those will come afterwards. So again, we tried to think through this. That's part of the reason I think it's taken so long. Boop-a-doop-a-doo. I'm gonna try really hard not to say this about a billion times, but it is it's the truth of the matter. I, believe it or not, folks, confession time, am not a Fender master builder. I know. That being said, the way that I go through my process is clearly not set in stone. It's like any other project we do. We're trying to give you guys some information so that you can not learn from our mistakes, but learn from our mistakes and maybe some of our expertise if you want to go that far. And you can also experiment and play on your own. I say it in pretty much every video that, great, watch our videos, learn from them, but it's not the same as actually slapping a piece of wood down and carving it and making mistakes and learning for yourself. So if you don't agree with something I've done, if you don't like the way I've done it, if you know a different or better method, share that stuff in the comments. Everybody's here to learn from each other. Let's keep it positive, because, you know, nobody needs to get grumpy with each other, but, you know, if you want to make a comment, keep it nice. That's kind of the bottom line. So follow along, don't follow along. I hope that I've thought through this process logically enough that you will see where I'm going with it and why I'm doing it. But again, if you find a better way of doing it, or if after going through my process you go, hey, you know what, I really like it, I want to try a different way. Try a different way. That's like, I can't stress that enough. I've got another body sitting there, can you see it? Another one there, and 2 other necks, plus these ones, and I still have to do one more neck because after I finally got a body that was good, I still want to do another neck just to make sure we're good. So like, again, I chatted with a couple people out in the community who have done some guitars, and after chatting with them, my own experience, and some other friends who I know who play guitars and, you know, can follow along with this kind of stuff, the reason I did things the way I did them was kind of twofold. The first is, we're a CNC company, and I wanted to show what this sucker can do. it's really cool that you even have the option of carving your own guitar in your shop with the machine that you have from us. So while there are other ways of doing things that maybe are a little bit easier, I didn't go the easier route. I'm going to say easier with air quotes because even the easier way is still tricky, guys. But I wanted to show off what the long mill could do. That was one part. The other part, oh yeah, there's two ways to do this, I guess you could say. Two ways, again. A million different ways, but two ways that I saw: vector-based and 3D model-based. The 3D model side of things, that's where I was going with why the long mill's awesome. I wanted to show off what the long mill could do, which is why I used the 3D model for a lot of this stuff. It helps that Andy supplied me with a model. And again, that's why we tried to think through this process so we could hand you guys the model as well. So at the end of the day, part one, I wanted to show off what the long mill could do, and that's why I did the 3D model way of doing this, because you can use just vectors. Absolutely can achieve, you know, I don't want to say the same results, but the same results. At the end of the day, you can get a guitar body with just vectors. There's pros and cons to both. So at the end of the day, how many times have I said at the end of the day? We may have to put like a counter. Bing. Whoa, we may have to rewind this. That's on you, Louie. At the end of the day, I found that even though the 3D model was awesome and the long mill rocked it, there were still a few parts that I did not enjoy with how they turned out. So I fell back on my old buddy, the vectors, because it just did a cleaner job. So I'm calling my method of making a guitar the hybrid method. And I say hybrid because it's not straight 3D model, it's not straight vector. I'm using both. I get to show off the machine, I get to show kind of two different ways of doing things, and then you guys can run with it and, you know, eventually do what you want. So that was a lot of talking. I don't know how much of that we're going to be able to edit out. I hope quite a bit, but I don't think we will. So we are going to move on to the, I think I have three big things I learned from carving my first, second, third, and so on guitars. So the first point, and as far as I'm concerned, kind of like the big one, again, from my experience, is order your parts first. I know that you're watching this video now and you're like, hey Scott, great, I'm watching a video, but I don't have my parts and you're telling me to order them now. Well, yeah, because I didn't. And I didn't have my parts on hand, and I carved the first one and then I got my parts and nothing fit the way like it was supposed to, because the model came from Fender specs, not necessarily genuine Fender specs, if you are picking up my drift. So at the end of the day, the first body I did, this guy, as cool as it looks, basically not useless, but kind of useless. It's going to be a sweet looking wall hanger. Buy your parts. Have your parts on hand. And that includes your neck. If you're not going to build a neck, order your neck. Have it sitting there waiting. Grab your, and these were a present that I bought. Can you see them? Digital calipers. I have some old school ones. I'm calling them the analog ones, and they work, but let's be honest, convenience is king. So get yourself a sweet pair of digital calipers, have your parts on hand. And you have your parts on hand because you're gonna watch me go through OnShape next, and I'm gonna show you how to tweak it, and you're gonna wanna be able to have your parts there. You can spec them right as you're doing it, and then you can go into OnShape, make some changes, because the odds are you're not ordering the exact same parts we are. Yes, I will throw the links to what we got in the description, but in the case that you don't order the exact same parts, you're gonna need to make some changes. So have your parts on hand. It will save you infinite amounts of trouble. One thing I learned. What is number two? Similarly, in the same vein as having all of your pickups, your bridge, your selector, all of your, you know, electronical kind of parts on hand. And, you know, your neck's not electronical, but you get it. Also, if you can, pick out your materials, your wood first. If you're just doing a body, the spec sizes are pretty simple to come by for a telly. If you're going to do something different, then find the dimensions for it. And the reason I say that is the first one that I did, it was wonderful. We did it out of plywood, and it has like this absolutely ridiculously accidental but wicked looking vintage relic look. But it was a royal pain in the butt. And the reason why was because unless you have like longer extended bits, which a lot of people don't have, I don't even have them, you will end up, your collet nut will get caught on the surface because it's too deep. It's just a pain in the butt. So if you can have your material on hand and the testers that you do, right? Tester, If you can make them the same dimension that your final product is going to be made on, it's going to make your life easier. And I say that because for version 2, it turned out really good, but I had to do dozens of workarounds because my material was too thick and I couldn't get my bit down. So I was using a bigger bit than I wanted to use. I had collet burns all over the top of the one because it was just too thick, the material. At the end of the day, get your material, your body, your neck. Fretboard's a little less important because it's thinner and it's pretty easy to manage, but get your material in, have it spec'd, and when you're doing your tests, make your test material the same size as your final material so that you're not doing and coming up with goofy workarounds. Again, dozens of workarounds on that one that wasted time, quite honestly, because I didn't think about that right. I just didn't know. So, point 2, have your final material on hand and make your test material the same dimensions so that you can just carve and it will be an accurate representation of what you're going to do in the end and not a bunch of goofy workarounds. Part 3, again, experience. I feel like there should be like some like huge orchestral music coming up because this is kind of a key point of all of this. It goes with everything we do, but this one is particularly tricky because it is a difficult carve. You guys are, if you're going into this, you need to expect you're going to make mistakes. Expect it. It will make you feel so much better when you do make a mistake. Again, that's why we wanted to do these videos the way we're doing them. That's why I've put so much effort into trying to kind of screw up as much as I could to save you guys some of the headaches that I have endured. That's a really long stretch from what it actually is. At the end of the day, work with cheap materials because you're gonna make mistakes. There's no point in buying a $150 body blank just to screw it up. First one again was plywood. I'll talk some more about that when we go into the actual body video, number 2. Plywood was great, it's cheap, it's easy to glue together, it's relatively flat to start with, awesome. The problem I had with plywood was that it dimensionally was not the same as my final piece is going to be, and again, ended up being a pain on my butt. Part 2, this guy here, which looks pretty decent. And this was a mistake on my behalf. That was I had my Z set wrong. Again, here's some burning. Can we see, a little bullet hole here? That was because even though this one looks really good, this was the workaround guitar. I'm okay with it because it was, what are they, 1x16 wide panels. They sell them in 4 or 6 feet sections. They're used for shelving. They're like $20 for a 6-foot board. You can get easily one guitar out of them depending on what you're doing, and then have a little bit of leftovers. It cost me, $15 to find out that I had a bunch of things still wrong and to work through the process. This was the expectation of making mistakes. The necks, I have 4 of them. The first couple were deck boards. The second 2 were just 2x4. So I know that saying cheap wood is kind of an oxymoron these days, but a 2x4 is a lot cheaper than something fancy, a flamed maple or something like that from the exotic wood places. So work with cheap materials, expect to make mistakes, and it will save you a lifetime of headaches because when you do finally get to one that looks halfway decent, ta-da! Again, I haven't sanded these. I haven't done anything to them. I've left them as they were carved on purpose because I wanted to see what the mistakes were so I could improve on them. Once you get to this point, you'll start to feel pretty good about yourself and you'll start to say, hey, I can actually do this and I can make a really rocking guitar, and it's a really cool feeling because at some point in the near future, this thing is going to be, electronified. We're gonna do a fretboard. We're gonna have it all put together. We're gonna finish it nice. We're gonna make a pick guard because it's a custom shape, and you're gonna get to sit back, stand back, and if you never play it for anybody and it only hangs on your wall, it looks really sweet. And if you do play it, then people are gonna go ooh and ah, and you're gonna feel like an absolute rock star more than you already do. So, those are my points. I apologize for how long that took. I really was trying to pare it down. I probably should have just read it. It would have been shorter, but then I would have sounded like a robot. So without any further delays, we are going to hop over into OnShape, and I'm going to show you how I basically took the parts that I had, spec'd them, and I'll show you how to make the changes because it is a little bit tricky, but I think with me showing you some of the ways that we do it, that if nothing else, even if you don't understand what you're doing, you'll be able to change it, you'll be able to export a file, and you'll be able to cut your own guitar. OnShape we go. Alrighty folks, We've got OnShape loaded up. You will be able to get the link from the description in the video, and it will bring up a screen that looks like this, only it's going to tell you that it is read only or view only. So you'll have to go and make your own copy. So you're going to go over to this little guy and copy the workspace, and it'll pop up a thing to rename it. It is a public document unless you have the paid version, so just know that for your general knowledge. From there, you know, OnShape is pretty cool as far as things go. It is the way to describe it, if you don't know, is parametric modeling. So it basically means you can kind of layer the changes you make, and you are able to go back to, say, you know, you made 5 layers. You can go back to layer 2, make a change, and it will go and ripple through all the way to layer 5. So it's like a super powerful undo, basically. Only with undos, you lose the work you've done. So, parametric modeling. From here, I mean, at the end of the day, I don't know how basic I want to go with this. To move around, you can just grab your middle mouse button and hold down, and that'll, you know, move you around this way. If you hold your right mouse button, you can kind of zip it around like this. If you hold Alt and your right mouse button, it kind of slows it down and makes it a little less groggy, I think. And your left mouse button is to select stuff. So it's pretty straightforward. I recommend heavily that you go in to OnShape, into our file, you know, the copied one that you make, and just mess around. Make a copy of the tab way down here. You know, you can go to the tab and you can right click on it and you can, I thought there was a make copy. Oh yeah, duplicate right there, right? So at the end of the day, you always have our file to go back to. It's beautiful. So if you make a mistake, you can always go back to ours and start from scratch. I'm a little paranoid and I like to have kind of backups. So every iteration of the bodies that I did, I created a new tab that was duplicated so that I knew if I did something there I didn't like, I always had one to fall back on. A command that I find pretty regularly helpful is if you right click and hit clear selection, because OnShape is a little funky when you're selecting and you'll understand why. Other than that, you've got your little rotaty cube up here, which will do all your different views, which is super handy. And if they're in a view and you want to move around, you can still move around freely, which is really great, because if you want to get to the bottom, let's say, ba-ding, there's your bottom. The big reason why I'm doing this part of the tutorial is it would really upset me if somebody said, we're going to teach you how to build a guitar, we're going to give you the files, and you can't modify it. Or we're not going to show you. Take your pick. That would drive me nuts. So that's kind of why we're doing this one first. You listened to my advice. You're probably going to watch the rest of the video now and see how to change it. And your parts haven't arrived yet, but when your parts arrive, you're going to come back here. So that was the reason we're going through this, was so that you guys can have somebody kind of help you walk through and you're not just hanging out there by yourself if you've never done something this detailed before. So I cannot speak to the thickness of Gibsons or any other guitars, but I know that Fenders are typically 1.75 inches. So right here, you have a variable that you can indeed change the thickness of the guitar body if you want to. We don't need to, we're not going to. The part of parametric modeling that can be a little confusing is that you have kind of what I'm grouping into two different not ways, what's the right word? Description. It's almost like you need two elements to make one thing happen. So you can't just go and extrude something necessarily. You kind of need to have a sketch to start from, which is where I have them turned off, the visibility turned off, right? So you can just click on the eyeball and you'll see that it will now show us the sketch, right? All of these dashed lines are sketchies, and then if I don't want to look at it anymore, I just go bloop and turn it off. So this all started from the main body sketch, which is what's right here, and we can turn that on. Now, if you go to a top view, there you go, and you click on that main body sketch, you'll see all the parts of it that are there, and it's like, okay, well, great, what does that do for me? Well, the reason I'm showing you this is because if you double click on that main body sketch, you see this little pop-up that comes up that tells you you are now in that layer. You're in the main body sketch. Green check mark will accept what you're doing. Red X will get it closed. The reason I'm showing this to you is because maybe you like what we got here, but you want to make your own shape. you want to monkey with it, because at the end of the day, you're unique and you're creative. It's the reason I'm showing you this is so that you can go in there. So all these lines that are blue means they're not constrained by anything. So you can do what you want with them. If you see black lines, a lot of times it will mean that they are constrained. There's a restriction on them and you can't just do whatever you want. It's linked to something. So for the body shape, let's just say, you know, you wanted this to be a little more funky, right? Whatever you want to do. Oh, maybe not that crazy, but like you can see that just by playing with these Beziers that you can change the shape of it. So again, you can undo it too if you want, Control Z, or you can go up there, which I don't think I've ever done. But yeah, you can click on any of these little guys. It brings up the curves, and if you want to make a change, you go ahead. And if you want a guitar that looks like that, then you can make a guitar that looks like that. If you want to stick with what we have, you don't have to worry about it. But that is how you're going to modify that particular thing. Cool. I like it as it is, so I'm just going to get rid of it for now. The next one that you're probably going to mess with, because again, you're going to order your pickups and your selectors and your neck plates, and the odds are pretty good they're not going to be the exact same ones that we ordered. Let's just, you know, call a spade a spade. You're going to need to go in and just modify them. So the pockets and the string holes. I tried really hard to actually name these things that were logical, or at least were sort of logical. So if you go into the pockets and string holes, you will see that there are pockets and string holes. And the string holes are what I call these guys. I'm sure there's a proper name for it. I didn't Google it, I'm not gonna lie. In order to change, what are we gonna change? What are we gonna change? I'm actually not gonna mess with that right now. Let's turn off the sketch for that. So what ended up happening originally was the body started as a flat plane sketch, and then it got extruded up. Oh, that's a fancy thing I wanna show you guys. Sorry, where am I going? Body sketch is off now. This is also important, or just fun to know. So with any of the things that are in this list, right, if you right click on them, you can suppress them, which means you are basically turning them off, which is really cool. And the easiest one to show you is the body edge fillet. So it was, you know, it's nice and round. And if we suppress that, so it's a right click, is it a right click? It's a right click. It's a right click to bring up that menu, and then you hit suppress and you'll see what happens. Ta-da! The fillet or the fillet, whatever you call it, edge is now gone. You turned it off, which is, again, this is this whole parametric modeling thing. So if you want to turn it back on, you right click and you unsuppress it and ding, you get it back. So you can do that for any of these ones, which is really cool. It may give you some errors if you turn some things off because things are linked again. So if you get an error, then just turn it back on. That's, if I'm being honest, that's what I did the first time I played in OnShape. I just went and started turning stuff on and off, and whatever caused an error, I didn't really just, you know, dig deeper. I just knew that it did. Anyway, the other cool part is you can right click and roll to here. So that would basically be, I don't want to call it the undo function, but it's kind of like everything that you've done past that just goes away and it goes back to that particular level. So in this case, let's say, we want to go back to just the body extrude, right? We'll go roll to here, and it will go back to, that's what it looked like after the initial sketch was made. So the initial sketch was made on that flat plane, it got extruded up, ding. So that's a roll too. And you can do that for any of them. And on the same hand, at any point you can right click and you can roll to end. Ding. So it'll ding, 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 ding. It'll bring everything back up. So you have roll to, what do you have? I think you got 3 options, 2 options, 3 options. You have roll to here, and then you have roll to end. So, you know, just so you know about those. And, you know, let's keep it simple. I know I'm bouncing around a little bit, and I'm probably not making this easier, but I'm going to try. If we just wanted to go back to the main body extrude, or any of these ones, I have extrudes listed on here because that's what most of these things are, either positive or negative extrudes. You know, if you want to go into any one of these, just like the sketches, if you want to enter into them to modify them, you can double click on them and you'll see that the depth was extruded 1.75 inches. It shows you what was selected in order to modify it. So the initial sketch had the pickups and all that stuff drawn on there. And if we would have only told it to extrude just the pickups, it would have brought those up and left everything else flat. So you have to select the faces. So that's what these faces are, and that's why naming things is fairly important. That's how you're gonna have to go into these levels to modify them, just as general knowledge, right? So I'm not gonna change anything there. I'm happy with what's going on. So to enter into something, double click on it. When you're done, green check mark it. The roll twos and the roll to ends are very nice to know. The suppress is nice to know. And the other thing that is fun to know is if you hover over any one of these elements on the left, if you look at your 3D model or whatever you're looking at, it will show you what that thing is. So if you're not sure what something is because my naming convention doesn't make sense to you, just hover over one of these and it'll be like, oh, that's what Scott's talking about. You know, front and back, they show them all, so that's cool to know. And now I think it's just a matter of showing you how to go into some of these and modify them. There is a couple that are a little funky because they are linked to things. And I'm not gonna lie, there's probably gonna be some people in the comments that are like, this is ridiculous. Why did you do this to me? And to those people I say, I'm sorry. We'll get you through. What are we gonna go into? I mean, at the end of the day, let's say something like a bottom pickup extrude. So my bottom pickup, this guy, right? Bridge pickup, take your pick, up. That was terrible. So if you double click on it, it's going to give you the extrude depth because that's what it was. And if you pull out your handy dandy digital calipers because you went and bought a pair because they're actually really cheap, and you measure what that is, it'll tell you the depth from the bottom of the bridge to the bottom of your pickup screw, because that's important to know, right? Obviously, that pocket has to be deep enough to enclose all that. So this is kind of the wash, rinse, repeat cycle that you're all gonna have to go through if you have different stuff. If yours was deeper than 0.945 inches, I think I left I'm gonna bounce back and forth between units. I think I left like a millimeter too, you know, a 16th, if you will, extra depth, just to make sure it was gonna sit in there clean. So that's the extrude portion of things. And it's the same for everything else, right? So these are all extrudes. You know, the selector pocket is going to, for me, it was deeper than this. So I made it a little bit deeper. I don't know if you can actually see that, but the electronic component on this guy went deeper. So we made the whole pocket deeper. It's never going to be seen, so it's not a big deal. So you just go through each one of the extrudes. That's personally what I would do. I would go through the extrudes first and measure my depths. Now, if you want to dive into changing the shape, we're going to get there. But at least you would know that all your depths for all your extrudes are correct. Changing the shape can be a little bit more excruciating because I believe you have to go back down to the main sketch level because that's where everything started. And I am correct on this. And this is where you're going to look at this and say, there is so much stuff on your screen right now, Scott. I don't know what's going on. I felt the same way. I fought through it and we got her done. So this is where I'm gonna try to help you guys out because at the end of the day, your pickups, if you're doing a tele style body like we are, should be fairly similar. But in the off case that, you know, maybe your radius is a little bit bigger or smaller because you got, you know, whoever made the manufacturers, there's differences, you know. So different tolerances, all the things. So in order to go in, you'll see that I've tried to put dimensions on a lot of things just so you can go in. Again, you can use millimeters or inches if you just type in your unit when you're typing in your dimension. So like, you know, 0.394 inches, if you put whatever the equivalent is in millimeters and put mm, it would put it in millimeters for you. So I'm pretty sure if you go up to the menu, you can change your workplace units as well. There you go. Mine's inches, so you would change this. I guess I should have went over that way earlier. My bad, maybe we'll cut that and slide it forward. Either way, there's your workplace units if you want to change it to whatever you want to change it to. I tend to bounce back and forth between them. So, as shocking as I'm sure you'll all find that. Here we are. So for example, this bridge pickup, which is what we're looking at right here. Ooh, that's not what I want to do. So I'm going to use that clear selection, right click clear selection. You can see that part of it is blue. The blue line means it's not constricted or restrained by anything, so you can actually move that around freely, but if you tried to grab this point and move it, you will not be allowed. basically there are other things telling it where it needs to be and why it needs to be there. So there is a, you know, a dimension line here that says the center of this circle's radius, diameter, radius, whichever I'm talking about. The center of this needs to be 0.988 inches away from the center line and 2.48 inches up from this center line that we've dictated. Again, I'm not going into how we're going to build this from scratch. I'm just showing you guys how to modify what we've given you so that you can make the same-ish thing we're doing and maybe get your feet wet with learning how to do some of this other stuff. I had to change this pickup a couple times because fender specs versus what we got were not the same. Even down to on our bridge, there's only 3 main screws to hold this thing down, and I believe on a fender there's 4. If there is, I apologize, and we're gonna have to cross that bridge at some point. But to change the shape of this, again, if it's blue, you can just grab it and, come on, move it around. There are gonna be certain restrictions on it because, again, it attaches to a black line, so it's not going to change everything, it'll just change that. But you can go into the dimensions as well, double click on them, and you know, maybe yours is 1.3 inches. Maybe yours is 1.3 inches. So again, you can type in the IN, it'll automatically do it. If you did it in millimeters, it will accept millimeters too. So whatever the equivalent is, whatever unit you're working with. I believe because my document file unit setup is default to inches right now, if I just type in the number, it will automatically assume it's inches. If I want it to be millimeters, I have to type in that mm, and obviously vice versa if you were to switch. If you wanted that to be, see, 1.3 instead of 1.2. This is where the good news is, if you're kind of using the same spec-ish pickups, selectors, bridge that we're using, even if they're not the exact same brand, they should be a similar shape and size. So you should really only have to go in and monkey with this a little bit, but that's what you're gonna have to do. Well, let's go into the wire guide one. So let's say that you needed yours to be a little bit wider for whatever reason. You can make a 0.65 and it'll make the whole radius, that circle, semicircle, a little bit bigger. But again, you're gonna have to go through, and all these dimensions are movable. So if you're not sure what it's for, you can move these around, and if you drag it outside, it'll still connect to it. But again, the center of this, if you need it to be something other than this, if it needs to be whatever, let's call it 1.5, just, oh, 15. Well, it still moved at 15, right? That was wrong. But at the end of the day, everything you guys are doing should be similar to what we're doing. You can go in, you can change the shape, and I'm trying to find, there we go, there's one with the radius on it, right? So this is actually part of a circle. So if you need it to be something other than times 2, why does he got a formula in there? Oh, let's see what happens if we make a 0.5 straight up. Yeah, so you can change those. I'm just going to paste that back in because I don't know what it was. At the end of the day, though, to move things around, you will have to, you know, oh, see, I punched that one as millimeters and it remembered that. That's cool. 45 millimeters, I don't know. So let's say this, we want to make this 3 inches instead. It's going to obviously screw it up. It's not where we want to go with it, but this is how you're going to maneuver some of these points around in this pocket. The selector pocket's going to be the same thing. That is a 1-inch radius on that. So if yours happens to be a 0.5-inch radius on it, then you make it smaller, and it's going to make it smaller. And in order to change its location, you will have to find the center points of where things are. So this is the part of OnShape where I would love to show you every single thing there is, but I gotta be honest, it's a little bit of legwork. I think I've given you a pretty decent basis for what you will need to do. Everything is pretty self-explanatory as far as naming goes. Again, all of these are just at the certain depths that they were brought to. You are going to need 6 string holes, and for the bridge screw holes, those are on there. I believe I have them. There we go. Those are the bridge, I called them bridge reference holes because I didn't actually screw all the, or drill all the way through. I just wanted to have a reference so that I can actually, I'm going to do those ones by hand, just to make sure that if I do need to have some play on here, I can, because these string holes are going all the way through. So my pocket for my pickup is a little bit bigger than it needs to be. And my through holes for my strings are going to go all the way through. So I figured if I needed to move those screws over by just a wee bit in any of the directions, that it was better just to have a reference than it was to have an actual hole drilled through. And other than that, I mean, that's kind of what I did for the ferrules too. If we flip over to the back side, you'll see that. So similarly to your pickup pockets and your selectors and that kind of stuff, these guys, what a pain in the rumpus this little baggie is. These are the little bullety shaped things that go on the back of your guitar for your strings to pull through and kind of lock in place. And I'm going to cut to a different video of showing what these are, but all I have done here is there's a lip, which is this first extrusion down right here. And then there's kind of what I'm calling like the main straight part of the body. That's the next extrude, but it also includes to the end of that. And so that main extrude is like this distance here. And then the last but not least is it punching all the way through to the other side. So you'll need to spec your ferrules, and that's where, again, where your digital calipers are going to come in super handy, because analog sucks for this. My lighting is terrible because it's like camera lighting. So, right, so yep, 7.9 millimeters. I'm pretty sure that's what I put in there. What do I call these? String holes, bridge. So if you bring up your sketch for this, you will see that it's in inches, obviously, but I used the pattern tool for this because it was just easier. Where is that guy? This guy here. The linear pattern tool. So I made the first hole. I gave it the right dimensions. I figured out how far apart they had to be, and I punched all those dimensions into here. So it made it super handy. I didn't have to make 6 copies of everything. I made one and it went all the way across. So that was pretty handy. And what else? Again, so if you want to change the dimensions of these because yours are different, then change it by double clicking. I doubt highly you're going to need more or less than 6 of them, so that's probably going to stay the same, but your spacing here might change, center to center. So you can double click on it and then you're good to go. And the same thing is going to go for, I think that's pretty much it, isn't it? Again, it's going to be some experimentation. I'm well aware that some people might find this a little daunting, but I think I've given you a decent enough basis to do what you got to do. That's the neck pocket. So if you did need to mess around with that, there's your neck pocket. So you can, sorry, it's hard to see the sketch. That's because it's laying right on top. And I guess the only other thing that, again, I'm well aware that this is not easy stuff and that there is a lot of clicking and there's a lot of stuff going on, so take your time. The only other thing that I'm going to throw at everyone to complicate things even further was, and this is why I say my method is the hybrid method, I found that when you brought the 3D model in and the way that VCarve interprets how to carve out the shape, it did this really nasty henpeck, I'm calling it, around, and it left a lot of tooling marks in the first one, and I didn't like it. So I had this, I want to call it a workaround because I'm sure other software probably thinks maybe smarter, and please, if you know why it did that and you can help me solve that problem, because then this workaround can go away, then let me know in the comments, because that would be wicked. But the way I worked around this nasty bunch of tooling marks on the neck and the body was to, in this model, whatever I was going to, I was basically going to use a vector to carve it out at the end to get rid of all the henpeck. But when you do that, it makes it smaller. So I came back to here, I made it a little bit bigger. So by the amount I'm gonna make it smaller or carve it out, I made it bigger here. I know this is getting confusing. I may have to put a diagram, right? I made it a little bit bigger here so that when we trim it out in VCarve, it trims it out and it ends up being the proper size. So that's what this trim thicken one is. So when it double clicks, it'll show you that I selected everything around the outside exterior of this. That's what the orange stuff is. And I extruded it, I thickened it by 0.02 inches because in VCarve, I offset it in by 0.02 inches, which left me with my original shape. So that might be a little confusing, and that took a little bit of work for me, and I may have to re-record this to, like, you know, make it clearer than I just made it, but I think that's fairly straightforward. That is kind of OnShape in a nutshell. Again, I apologize if I bounced around. There is a lot of info there. Hopefully this is helpful. This is, again, the first video of a whole bunch. Maybe if we release it and you guys are finding that it was not helpful, please comment and say, Scott, this was not helpful. It was more confusing. And maybe I'll re-record it and try and make it even better. But at the end of the day, this is kind of the first step in the rest of the fun journey of making your guitar. So have your stuff on hand, get your calipers out, measure it, monkey around in OnShape. Again, it might take you a little bit of time to really figure it out. I'm not gonna lie and say that I came into OnShape the first time and like, woo, was a master. No, no. I'm still like uber rookie, but I was able to go in and mess around with this enough to make clearly, you know, what looks like a pretty decent looking guitar so far. So it can be done. If you're having any trouble, let us know. We'll try and help you out as much as we can. Check out the Googles, check out the forums. There's lots of people posting about things on there. And that's about it for this first one. It is getting long in the tooth for how long I wanted this to be, but it's a lot of information to share with you. So I'm gonna wrap it up. I hope you enjoyed it. Hope you found it helpful. If you're gonna comment, keep it nice and we will do our best to help you. And the next video, whenever we get around to releasing it, will be all about carving out the body and how I made my way through that journey too. So we will see you sooner than later with the next awesome installment of the guitar series. And I guess we will see you around the CNC, guys. Thanks for watching. Boop-a-doop-a-doo, ba-ba-ba-ba-ba-ba, doo-loo-loo-loo-loo, ha-ba-doop-a-doop-a-doo, ba-ba-ba-ba, ba-ba-ba-ba, I'm trying to find, ba-ba-ba-ba, ba-ba-ba-ba.